Nice to see you on Khazar Chuktai and you're watching my YouTube channel, School of Advanced Chemistry. Today I'm going to explain exothermic reaction for IGCSE and O-level chemistry students. Let's talk about it. First of all, let me explain the energy and a chemical reaction mutual relationship. Basically, each and every chemical reaction is associated with some kind of energy, especially heat energy. So, during the chemical reaction, old bonds break down and new bonds are formed, basically. So in every chemical reaction, in all chemical reaction, there is the breakage of old bond and there is the formation of new bond. Heat energy is taken in when bond break down, and this process is said to be endothermic process. When the bonds are broken down, at that time, the heat energy is taken in by the chemical reaction. So this process is said to be endothermic. Endothermic mean endo mean to enter, therm mean heat. So these type of chemical reaction are going to take in heat energy whenever they are going to proceed. So bond breaking is basically an endothermic process. Whereas heat energy is given out when the bonds are made. When new bonds are formed, heat energy is given out, and this process is said to be exothermic process. Exo stand for exit, therm stand for heat. Basically, exothermic, endothermic, these are the Greek words. Exothermic mean when heat is given out, endothermic mean when heat is taken in. So basically, these are the basic meaning of endothermic and exothermic reaction. However, both processes occur simultaneously during the course of a chemical reaction, and overall heat energy change is known as enthalpy change of the chemical reaction. So both processes are happening at the same time simultaneously during the course of a chemical reaction. There is an endothermic process, there is an exothermic process. But the overall heat energy change is said to be enthalpy change, and it is denoted by delta H. That is the net result of these two major processes. Now let's talk about enthalpy. Enthalpy is the measure of total energy of a system, and change in total energy of a system is called change in enthalpy, and it is denoted by delta H as we have seen on the previous page. This enthalpy is basically denoted by the symbol that is H. Capital H means enthalpy. And what is enthalpy? Enthalpy is the total energy of a system. Total energy of reactants is called the enthalpy of reactant. Total energy of the product is called enthalpy of the product. And overall, when there is change in energy of the system mean the whole chemical reaction. Reactant plus product is called system. System, anything that is under observation, any happening that is under observation is said to be the system. So the total energy change in a system is called enthalpy change. Total energy of the system is called enthalpy of the system. Total change in energy of the system is called change in enthalpy of the system, or enthalpy change of the system, and it is symbolically represented by delta H. Delta mean change, H mean in enthalpy, change in enthalpy or enthalpy change. Value of delta H may be positive or it may be negative. If the answer of delta H is positive, the reaction is endothermic. If its answer is negative, then reaction is exothermic. So whenever we are going to calculate the answer of delta H by different means, through any mean, if the answer of delta H is equal to positive, it means that the overall process, the winner process, the major and main process is endothermic. So overall reaction is said to be an endothermic reaction. If the answer of delta H is equal to negative, then overall reaction is said to be an exothermic reaction. I mean, if the answer of delta H is equal to positive, reaction is taking heat from the surrounding. Reaction is taking heat energy from the surrounding. And if the answer of delta H is equal to negative, then it means that reaction is basically expelling heat to the surrounding. Unit of delta H is kilojoules per mole. These are the specific basic unit of change in enthalpy. Now let's talk about exothermic reaction. Exothermic reaction are those that release heat into the surrounding environment during the course of a chemical reaction. So reaction, if it is going to expelling the heat, overall reaction that is going to release the heat towards surrounding environment, it's said to be an exothermic reaction or exothermic chemical reaction. Exothermic reaction lose energy to their immediate surrounding. So the enthalpy or energy that is said to be the H of the product is less than that of the reactant. As the reaction mixture is going to lose energy, towards surrounding, then it means that the product are going to have less energy at the end of the chemical reaction. The product is having less energy as compared to the reactant, and answer of delta H is equal to negative. The answer of delta H, the integer of this exothermic reaction, will always be equal to negative. As a result of exothermic reaction, more stable product is formed. And the next one thing is exothermic reactions includes, this is the important point of this whole lecture, you can say, what are the basic reactions? Those can be known as exothermic reaction. You'll have to remember the list. Combustion reactions, all burning of coal, natural gas, burning of oil, burning of hydrogen, and so on. All type of combustion reactions are said to be exothermic reaction. For example, explosions, metal displacement reactions, precipitation reactions, respiration reaction, and acid-base neutralization reactions. These all reactions are said to be examples of exothermic reaction. Combustion reaction, combustion of coal, gas, oil, etc. Explosions, metal displacement reactions, precipitation reaction, respiration reaction, acid-base neutralization reaction. Radioactivity is also a famous exothermic process in which atoms releases their energy during their activity. So radioactivity is also an exothermic process in which atoms are releasing energy towards surrounding as the emission of alpha, beta, and gamma radiations. Exothermic reactions are often spontaneous reaction. They are happening themselves. No extra force, no extra catalyst heat is required for the happening of this kind of chemical reaction. Exothermic reactions are often spontaneous reactions. Next one, there is energy profile diagram, and I will explain energy of activation in a different topic. Here I'm going to simply generally explain energy profile diagram and energy of activation, generally speaking, as far as the exothermic reactions are concerned. There is an hypothetical graph or hypothetical diagram, you can say. On y-axis, we are taking enthalpy, and on x-axis, we are taking the progress of a reaction or the reaction pathway or the path of the reaction, basically. Let's suppose we are having the reactants that is having enthalpy that is equal to 50 kilojoules per mole. 50 joules or 50 kilojoules per mole. So what is basic demonstration of exothermic reaction? First of all, reactants gain energy to cross a huge barrier that is called energy of activation barrier. And finally, they move towards to make a new compound that is said to be the product. Then it is said to be the product. So this is the total journey, symbolic representation, you can say, that is a symbolic representation. And for example, a man is standing over here and it is moving from this position to the other position. And these two positions are quite different with respect to enthalpy, with respect to nature. A man that was standing over here is not the man that is now standing over here at this place. I mean, this is the path, this is the route of the chemical reaction, basically. So first of all type of reactant has to gain energy of activation. After gaining that energy, their bonds are completely break down. And finally, there is the formation of the new bond. And finally, we are having the new shape, new entity, new species. Those are said to be the product. So once again, you can see that the energy of the product is less, that is 25, for example, in this case, and energy of the reactant is 50, for example, in this case. So energy of the product is less than that of energy of the reactant. So simply it means that profile, that history, that reaction pathway is showing the reaction, the nature of exothermic reaction. Now let's talk about temperature time curve for exothermic reaction. For example, I'm going to measure the temperature of a vessel in which an exothermic reaction is supposed to happen, and we are keeping it at room temperature. So what happened with the passage of time? Initially temperature rises, and finally initially temperature rises to a certain limit. Then finally, after some time, you can say temperature decreases and it becomes equal to the room temperature. So this is the history of temperature time history, temperature time curve with respect to the vessel of that reaction, I mean the container of that reaction. Because during the course of an exothermic reaction, initially you can say the vessel become hotter and heat is expelled out. When heat is completely expelled out, then again this container keep itself at the room temperature. That is the brief demonstration of change in temperature with the time during the course of an exothermic reaction. That's all about this reaction, this topic. Thank you very much. Have a nice day. Please subscribe my channel, hit the bell icon and share it with your friend. Thank you very much. Bye.